Okay, good morning, girls. How are you? Okay, today we are going to be revising lesson 15.2, which is called Modeling Exponential Growth and Decay. In this lesson, we only actually were introduced to the growing and the decaying model. We said that for an exponential function, it's either increasing, going to infinity, or decreasing, going to negative infinity, either decaying or increasing. And you were introduced as well to the meaning of this word, the word asymptote. If you remember, we are going to be, yes, here, an asymptote. We are going to be revising it. Asymptote, as we said, is when you graph your exponential function. The asymptote is the line which is very, very near to the function, but not actually cross it. And in here, we were introduced to the exponential growth model, which is y equal to a1 plus r to the power of t. We mentioned this yesterday. And then we said, what is the value of a? A was the initial value, my initial value. And since we are talking here about real world life, most of the time a was positive, not negative. So we are always talking about quad 1 in the coordinate plane. A was most of the time positive. What was the value of r? R was the growing rate, or the growth rate. 1 plus r as a whole was the growth factor, and t is the time. And then we were introduced as well to the exponential decay. It was the same thing, but except instead of 1 plus r, it's a 1 minus r to the power of t. And a is the initial value, or the y-intercept, and r is the decaying rate, and t is my time. Okay, I did a revision sheet for you. We are going to be solving from it. This is lesson 15.2 revision. And as yesterday, it consists of 3 questions, question 1, 2, and 3, covering most of the concepts of, most of the important concepts of this lesson. Okay, let's start with question 1. Let's read it. Write an exponential function to model each situation. He didn't specify here either it's growing or decaying, because you have to understand by yourself. As I told you, when you read the word increase, when you read the word grow, when you read the word add, something like this, most of these words mean growth model. When you read the word decay, decrease, less, so it means decaying model. Okay, so after you write an exponential function, determine the domain, determine the range, the asymptote, and then find the value of the function after the given amount of time, and what does y-intercept represent in this situation. And as I told you, remember, when you are talking about real life situation, there is no negative. What do I mean by there is no negative? When are you talking about time? Is there a negative time? There is no negative time. Yani, what do I mean again? When we are graphing exponential function, actually the exponential function will be like this, as we graphed yesterday. And for example, if it was increasing, it's going to be like this. This was my increasing function, for example, right? In here, you involve the negative side of x as well the positive side of x. This is what I mean by negative and positive. What if x was time, for example? What if x, according to my real life situation, was modeling time? Is there a negative hours? Is there negative time? There is no negative time. That's why this part is going to be just like erased, and you are going to be left with only this part. Yani it's going, the graph is going to be like this. I don't have this part. This part is not here. I'm going to start with the y-intercept wherever it is. This will be my point, wherever, up, down, whenever, and going, for example, up, or going up if this was what? If this was growth, and this is growth. And going down if this was decay. I will be going down if this was decay. if this is decay, you will find your graph in this way. Will it pass to the negative side? No. Will it bring the negative side in here? No. So it will just be decreasing like this, but it will never pass to the negative side. And for the red one, this is going to be representing the decay. That's why I'm telling you, when you are modeling a real life situation, there is no negative parts in here. It's not coming here, it's not coming here, it's not coming here. We are going to be focusing on only quad one, which have the positive values representing positive real life situations. Okay, so going back to our question, let's read the first question. Annual sales for a fast food restaurant are 650,000 and are increasing. I read the word increasing. Increasing, so this is growing or decaying model. The first thing I understand that this is going to be growing model. Let me solve in another color. Let's do it in red. So this is growing model, right? So let's find what is the value of A, what is the value of R, and what is T. A is the initial value, which is very obvious, this. So I have 650,000. What is the value of R? R increasing at a rate of 4%. So the 4% is my R. So R is going to be 4%, which is 4 over 100, which is 0.04. So we found R. What else? The T is 5 years. So T is equal to 5 years. I found T. Now I can write my exponential function. F of x will be equal to A, which is 650,000, multiply 1 plus 0.04, which is the R. All of this to the power of what? Yes, we have to write it in the exponential form, sorry. Yes, so here it's going to be 1 plus 0.04, close the bracket, and then up here I should write what? I should write 5. So 1 plus 0.04 power 5. So here we wrote our exponential function. So the first part is done. Now I need to determine the domain, the range, the asymptote, and find the meaning and the value of the function after the given amount of time. Actually, for the value or the given the value here, you are going to just use your calculator to substitute to find the value. 650 multiply 1 plus 0.0 power 5. You will find the answer. I will write for you the answer at the end. Okay, I need to find the domain, the range, and the asymptote. You remember domain was all values of x, and range was all values of y, and the asymptote is, as I told you, the line which is coming very, very near to the function, but never really touch it. Actually, to find it, I have to imagine what will be the shape of my function. Since he didn't give me here a graph to graph, or he didn't give me like points or whatever, if you go back to the lesson, some problems he gave you a table and gave you a graph, and you were required to complete the table and graph the graph. So using the graph you will be able to. What if he didn't give me, and in here he didn't give me a table nor graph, nothing? I have to imagine. Now, I understand that if this is growing model, it will be this shape. Now that's why we graphed it. So it will be this shape, right? So I am talking about the growing model. So this will be my shape, right? This is what I understand. This will be my growing model. And this value here is the y-intercept, which in our case, in our problem, it is like 650,000, which is the $650,000. Let's see, what is my values of, what is my domain here? What is my domain? The domain is values of x. So I'm looking at x. Yes, x is coming from what to what? from 0 to infinity. Is there any negative part? No. You remember we said for a normal exponential function, the domain was all real numbers. When we talked about normal exponential function, when it was growing from here, coming from negative infinity to positive infinity and going like this, I told you, yes, it's going to be what? All real numbers. But since we removed the negative part, I only have positive part now. So the answer is going to be what? All positive real numbers. So actually my domain is all positive real number. What did I do to solve this? I grabbed it in my mind or grabbed it in a piece of paper in the exam or grabbed it like in a side paper to understand. I know that grow is like this. Since we are talking about money and we are talking about years, there is no negative, so there is no this side. So my graph is only from here to here. That's why it's going to be all real, but all positive. So all positive real numbers. So this is my domain. What about my range? Before as well, when we talked about this, my range was starting from 0 to infinity. I'm looking at y, since I don't have negative part. So it was coming from 0 and going up. So it was all, yeah, like we wrote it in an inequality y greater than 0. But in here, in here your initial value was 0. But in here, is your initial value 0? What is your initial value? You are starting from the y-intercept, which is this value, and going to infinity. Are you going a little bit down? No, this is my first value. And my graph is the black one. It's starting from this point. There is nothing in any other part. So this is my first part and going to infinity. So I'm going to say my range is y greater than or equal to 650,000, which is y greater than or equal to y-intercept. Very well. So let's write this. So using the graph which we graphed, my domain is going to be, I'm going to write for you in here, using graph, the domain is all positive real numbers. What about the range? The range is y greater than or equal y is greater than or equal to y-intercept, which is actually what in this kind of question, it's going to be y greater than or equal to 650. Okay, very well. Let's find the asymptote. So we wrote the equation. We will find the solution. The domain using the graph, which I did in my mind, it's not to be grabbed. Just understand the shape and then you will be able to find the domain and range. We need to find the asymptote. Okay, what is the asymptote here? To know the asymptote, we have to go to the graph that we graphed again in the whiteboard. So this is my asymptote. I am again talking about drawing, so I'm talking about the black function. What is the line which come near to the function but never cross it? Y-axis? Actually, no. Y-axis already crossed my function in 6, because this is the y-intercept. But x-axis is my asymptote. Actually, for the exponential function, the asymptote will be most of the time x-axis. So it is x-axis. And then what else does he want to find? Yes, what does the y-intercept represent in this situation? The y-intercept is what? What is the y-intercept here? The y-intercept is the initial value. The y-intercept is the initial value, which is here equal to 650,000, which represented the what? Let's read the question. The annual sales. The annual sales. So at the beginning, we can write the initial annual sales. So it represents the initial annual sales. Okay, very well. Let's go to the second part. So let's read question 2. Question 2, the population of school is 800 students and is increasing at a rate of 2% per year, 6 years. Again, since I read the word increasing, so this will going to be a growing model. So again, this is growing model. Let's find the value of A and the value of R as we did. A is the initial value. What is the initial value here? The 800, the population of students. So A is 800. What about R? R is at a rate of 2%. So 2%, which is actually 0.02 when you divide it by 100. And then what about T? The T is 6 years. So now let's write the equation. The equation is going to be f of x is equal to A, which is 800, multiply 1 plus R. So in here, 1 plus the R, which is 0.02, power, what is the power here? Power 6. Very well. And then putting this on the calculator and finding the answer. The answer will be whatever. Okay, we need to find the domain. What is my domain? Actually, without even looking again at the picture, this is growing model, right? So it's going to be going up. So again, the domain is going to be what? All positive real numbers. If you practice on this a lot, you will not be needing actually even to graph it many times. It will be stuck in your head. What about my range? My range, as we said, since this is growing, so the starting point is the y-intercept, and the y-intercept is always what? Always A. So here it's going to be y greater than or equal y greater than or equal what? 800, which is the y-intercept. It will be the beginning value. What about the asymptote? Most of the time, asymptote is x-axis. Now we need to define the y-intercept. What is the y-intercept in here? The y-intercept is, what is the definition of y-intercept? The definition of y-intercept is the initial population of school. The initial, because he's telling you the population of school in the beginning is 800 students, and then it's growing per year and these things. So the 800 is the initial population of school. So the initial, and let me even write the number. It's 800 for him to understand that I know 800, which represent the what? The initial population of school. Okay. Okay. Let's go to question 2. 3. Yes, question 3. The population of a town is whatever and is decreasing at a rate of 3% per year. 3% per year. Decreasing. So I am talking now about a decaying model. I am talking now about a decaying model. Right? So let's find the values that needed. A will be the beginning, which is 500. And R is 3%, which is 3 divided by 100, which is going to be 0.03. We found the R. What about my T? It's a 5 years. Let's write the equation. So f of x is going to be A, which is 2,500, multiply 1 plus R, which is 1 plus, no, not plus. We are talking about decay. Yes, take care. You wrote here decay model for this, not to forget. I was going to forget. So this is a decaying model, so it's a 1 minus R. So it's a 1 minus 0.03. Okay, and then power. What is the power? Power 5. Here it's a 5, so power 5. And then you will find the solution using the calculator. You will find the answer in here is going to be equal to what? I will write for you the answers at the end. Now we need to find the domain. Okay, domain. This is a decaying model, right? So if we go back to the whiteboard, decaying model, so it's the gray, the red one. We are talking in here now. The growing, well, the population of the town started at the population of the town started at here to 500, and it's decreasing, right? So it started in here and then it's decreasing, decreasing, decreasing. So it's the decaying model. So what is my domain again? My domain is, again, I'm starting in this value of x at 0 and then going to infinity. So again, all positive real numbers. So the domain is the same, all positive real number. You didn't go to the left. So it is again all positive real numbers. What about the range? The range in the growing model, we said we started here and then we are going to infinity. But in here, I started here and I'm going to negative infinity. So I mean, is y greater than or equal to this number? If it's greater than or equal to this number, it's going up. But actually, no, y is less than or equal to this number. And if I try to write this, actually here, y is not going to the negative infinity. Y is from, it's starting from 500. I mean, what do I mean? The 200, 500 thing is a people, number of persons. The number of persons started in the town was 2,500 persons. And then as year goes on, the number of persons are decreasing, decreasing, decreasing. Will they decrease? What is the least number of persons you can find in a town? No one. And no one means what? 0. Is there a negative person? Can you reach negative 1 person or negative 1,000 person? No, I can't reach negative persons. So I can say that the maximum number of persons is this, and the minimum number of persons is 0. So we can write that y, the range is starting from 0, or starting from 0. This is the minimum number. You know, whenever you are writing an inequality, you have to begin writing from the minimum to the maximum. You have to begin writing from the minimum to the maximum. That's why I am telling you y will be greater than or equal to 0, less than or equal to 200, 500, 2,500. So I'm going to write in this way. My domain is again all positive real numbers. But for the range, it is what, as I told you, it started at a certain number and reached 0. But since we are writing an inequality will always be written in this way. You will always be having this, and here y, and then this. And you have to write the minimum number here and the maximum number here. This is always for the decaying range. The minimum number is 0 or 2,500, it's 0. That's why I write the minimum number in here in the beginning, 0. And in here, what is the maximum number of persons you found in the town? The 200, the initial value you started with, 2,500. Okay, very well. So for the decaying model, it's always like this. For the growing model, it's always y greater than or equal to y-intercept. In here, it's always y greater than or equal to 0, less than or equal to y-intercept. Okay? Okay. What is the y-intercept in here? The y-intercept here is the 2,500, which represents the initial amount of persons or population of the town. Okay. Okay, very good. Now I'm going to leave question 4 for you. Try to do it and send me the answer. It is in the same way, so you are going to be doing it in the same way. Okay. Okay. Let's go to question 2. Write an exponential growth or decay function to model each situation, then graph each function. And this time he is giving you the graph to graph it. And we need to do even the table. Okay. So let's do it. Okay. For question 2, write an exponential growth or decay function to model each situation, then graph each function. I read the first question. The population of 20 is 20,000 now and is expected to grow. Since it's expected to grow, so this is a growing model, so I went and wrote the exponential growing model, which is f of x equal to a. This is a. 1 plus r. Of course, this is r. How did I find r? 5 divided 100. It became 0.05 to the power of t. We don't know what is t, so I left it as it is, unknown. For number 6, about that cost, whatever this word, depreciating, we said that before this word means decrease. This word means decrease or decaying thingy. So since it's decay, so I wrote the decaying model, which is going to be 1 minus. So f of x is equal to a, which is my initial value. 1 minus r. What is the r? The 20%. 20 divided by 100 is 0.2 to the power of t. So we finished writing the exponential growth or decaying model. Now I need to do what? Graph each function. Since he didn't give you a table in here, since he didn't give me a table, so I went and see the graph. Just go and see the graph. If we went and see the graph, this is the graph that he gave you, right? This is the graph that he gave you. I need to do a table for x and y. We always put values of x. Do not put values using your mind. And do not tell me, teacher, I'm going to put negative 1, 0, 1, 2, because this is what we are used to. No, dear. First of all, we said this is a real life situation. There is no negative. And then you have to use the graph given for you. The graph in here, this is x, and I have the values 2, 4, 6, 8. So it's better to use the values that you already have inside the graph. So that's why I put 2, 4, 6, 8. I can even add 10, but 4 points is enough for me. And the same thing, I went in this graph and find 2, 4, 6, 8. That's why I put it in here, 2, 4, 6, 8. Now what should I do? Now we should do some calculations and finding these values. I'm just going to do what? The x actually is what? Is the t. The x is actually the t. You know what? Actually, we shouldn't write x in here and t in here. And this should be, if this is x, so we should put an x in here. Now, let me just do it. So I used my function, which we had in here. I used my function to make this table. As I told you, these points I took from the graph. You can take 0, by the way. 0 is the initial point. So we already know that at 0 is going to be 20,000 because this is the initial, this is your y-intercept. And then what did I do at 2, 4, 6, 8? I just used the calculator. I put, instead of x here, once I put 2, I found that the value is going to be 22,050. And then I put 4, I found the value to be 24,310. I put 6, it was 26,801. I put 8, it was 29,549. Now I'm ready to graph. Okay, let's try to graph together. I'm trying to put the points. And as I told you before, doing the points on this kind of function, it's the small errors is acceptable, I know. But actually we need to make it bigger. Okay, let's try to make it bigger. Yes. Okay. So let's try to do the graph together in here. First of all, I have the point 2. First of all, I have 0 and 2000. This is the first point I know, 0 and 20,000, which is the y-intercept. We didn't need to write it on the table. So this is my first point. And then I have 2 and 22,000 something. Since this is 20 and this is 30, so the one in the middle is 25. So 22 will be in the middle, in here, like in here, right? And 2, so we can say that the point is in here, for example. Okay, let's complete. 4 and 24. Since this is 25, so 24 will be slightly under it. So 6 and this is 25. I need 24, so we can just try 4. Sorry, what I'm doing 4. 4 and 24. Yes, 4 and 24. So 4 and 24 in here. We can say it's in here. Yes. And then 6 and 26. 26 will be slightly above 25. So 6 and 26 we can write in here, for example. And then I have 8 and 29. We have 8 and 29. So 29 will be just below what? It will be just below the 30. So in here, for example. And then using your hands, because this is depending on our hands, we said before, just connect the points together. Of course, your hand will be much better than mine. It will be something like this, for example. And this is my growing model. This is my growing model. Then you are going to be doing the same thing for the second function, which is the decaying function. Again, 2, 4, 6, 8. You are going to be putting the numbers and then completing the table and then start graphing. This time it should be going down because it's a decaying model. I will leave this for you as well and try to do it and send me the answers. Okay, very well. Let's go to the last part of the revision. Okay, the last part of the revision, question 3, state each function, domain, range, and end behavior. You remember the end behavior? As x goes to whatever, y goes to whatever. You remember? And asymptote. This time, girls, take care between the difference of these functions given in here and the functions in the first 2 questions. The functions in the first 2 questions represented population of students, represented population of town, represented money of in a bank, represented money of boats. All these things is representing a real life situation. That's why we said we don't have negative in real life situation. That's why we only worked in the first quad. In here, he is giving you a function. Did he tell you it represents anything? He didn't. So this doesn't represent a real life situation. This is a normal exponential function. I mean, it's going to be dealing with positive, negative, going up, going down, because he didn't tell you it represents a real life situation. Take care between the difference of question 3 and question 2 and 1. 2 and 1 is a real life situation. That's why we stopped at 0. We didn't go to the negative part. But in here, you have a normal exponential function, so you can go wherever you want. Draw the normal function, the exponential normal function. First of all, how can I state the domain and range without graphing? I have to graph, right? You remember yesterday when I recalled for you the 4 graphs that we have for the exponential function? When a is greater than 0 and b is greater than 1. When a is less than 0 and b is less than 1. The 4 graphs that we took. This is what you are going to be using to try to find the domain, range, and end behavior. Let me think with you. First of all, I have this function. I am going to ask myself, what is the value of a here? A is what? A is 900. It's greater than or less than 0? It's greater than 0. So it's going to be in the positive part. It's going to be in the positive part, yani up. Okay, very well. What about B? B is this number in here. This is B. So B is 0.65. 0.65. Is this less than or greater than 1? It's less than 1. Since it's less than 1, so it's going to be decaying or increasing? It's going to be decaying. So I understood everything. Now I can graph it for myself. Let's try to graph it for us. Let's try and graph it for ourselves. Like this and like this. Since A is positive, so I'm talking about the positive part, not down. Decaying, so it's going to be decaying. Very, very bad graph that I did. Very bad graph. I have a very bad steady hand. What is happening for me? This is the importance of schools, is for you to know how to graph carefully. Okay, anyway, I finished. Okay, this is my decaying function. From the graph that I did with my own hand, yeah, with my own mind, I didn't do a table, I didn't take points, I did nothing. This is just for me to understand the shape. I can find the domain and range. Let's find the domain and range. The domain is, this is not a real life situation. The domain is ranging from negative to positive. So I'm going to tell him that actually the domain is all real numbers, positive and negative real numbers, because this is not a real life situation. What about the range? Yes, here. What about the range? What about the range? The range is, what is the least value of y? It's 0, and then it's going up to infinity. So I can tell him that y is greater than 0. Why didn't I put an equal here? Because will it ever reach 0 really? It will never reach 0. It's always touching 0, but it never really reached 0. This is opposite to the y-intercept. The y-intercept is really happening. But 0, as I told you, exponential function never ever reach 0. It's nearly equal to 0. That's why I didn't put an equal sign. What about the asymptote? Again, we said that the asymptote is always what? What is the line here touching the function? Is it y? No, y is not touching. Y is cutting the function. X-axis is touching the function. So the asymptote is x-axis. And then the last thing I need to find is the end behavior. Let's write the end behavior as x. And then you are going to do like as x. But since I don't have the arrow thing, okay, we will try to graph it. Y goes to, and in here, as okay, so this was my graph. Let's do the end behavior. As x goes to infinity, what happened to y? Where is positive infinity of x? As we said, this is your x, this is negative infinity of x, this is 0, and this is positive infinity of y, of x, sorry. So as x goes to infinity, I'm looking at the far right. What is happening to my function? It's going down, going down, going down, but will it ever go down to the other side? No. So the least value that it will reach is 0 at y. So as x goes to infinity, y goes to 0. As x goes to negative infinity, now I'm looking at the left. What is happening at the left? Y is going up, 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 up till positive infinity. So y goes to infinity. Y goes to infinity. Okay, very well. Let's go to the last question. f of x equal whatever. First of all, as we said, I have to identify the values. So a is 80, it's positive. B is 1.23, it's greater than 1, so it's increasing, right? So I can write, or I can draw the function for myself. Since it's positive, a is positive, so it's up. Since it's increasing, so let's grab the increasing function. This is my function. Now let's find the domain and range. Again, the domain is, what is the value of your domain? All real numbers. All real numbers. All real numbers, because you are talking about positive and negative. What about my range? Range again is starting from 0 going to infinity. That's why I'm telling him y is greater than 0. But I will not put an equal. And then what about the asymptote? The asymptote will never change, guys. It's always x axis. And then let's write the end behavior. What will happen as x goes to infinity and as x goes to negative infinity? As x goes to infinity, what is happening to y? And I'm looking at the right. Y is going up. So y is going to infinity. Up means infinity. As x goes to negative infinity, I'm looking at the left. Y is stuck in the middle, which is 0. It's not going down. It's only at 0. So y goes to 0. Very well. We finished our revision today. Please send me back this revision sheet with your answers, just to make sure if you have any problems. And be tuned for tomorrow's online Zoom lesson, inshallah. I will be answering all of your questions and try to prepare lesson 16.1. Thank you and goodbye.